Alright, welcome back everybody. In this video we're going to talk about slope fields and how we create slope fields. What a slope field is it's basically a graphical way for us to show what all of the possible antiderivatives of a differential equation can look like. And they're really super easy to create and use. Basically, what we have here is we have a differential equation. And if you remember, the derivative represents the slope of a particular function. And so if we sketch all of the possible slopes using this differential equation, the picture that we'll see is we'll see kind of a map that shows what all of the possible antiderivatives, the whole family of antiderivatives, looks like. So basically all I'm going to do is I'm going to take this differential equation that I have, dy dx equals x minus 2y, and I'm going to substitute in the x and y coordinates at various points and calculate what the slope would be at that point, and then just sketch in a little hash mark representing that slope at each of those points. So I'm going to start at the origin 0, 0. So I put 0 in here for x and 0 in here for y and calculate the value, and I get that the slope is 0 there. So I'm going to draw a slope line with a slope of 0 at the origin. And then I'm going to move around, and I have 25 total points here where I'm going to calculate the slope. And so I'm going to go ahead and do that. I'll go over to 1, 0 next. If I substitute that in, I calculate that the slope is 1. So I'll put in a hash mark with a slope of 1. If I put the point 2, 0 in, I have a slope of 2, so I'll put in a hash mark there with a slope of 2. Over here at -1, 0, I've got a slope of -1. And over here at -2, 0, I've got a slope of -2. And so that's really all I'm doing is drawing in these slope lines. Now I'll move up to where y is 1. When x is 0 and y is 1, the slope is -2, so I'll put a slope line with a slope of -2 there. When x is 1 and y is 1, my slope line has a slope value of -1. So I'm drawing a -1 slope there. And at 2, 0, the slope is, or pardon me, at 2, 1, the slope is 0. And over at -1, 1, my slope is -3. I'm going to draw in a slope line with a slope of -3. And at -2, 1, my slope is -4. So I'm going to draw in a slope line with a slope of -4. Now the steeper these slope lines get, the harder it is to tell, the difference between -6 and -7. You want to make sure that you get your slope lines with approximately the right relative magnitude in the slope, and we definitely want to make sure we have the right signs, positive, negative. We want to be able to tell the difference between a slope of -1/2 and a slope of -1, and the difference between a slope of 3 and a slope of -2, certainly, but it gets a little difficult when we get into the higher slope values to tell a huge difference between them. Hopefully you can tell the difference between the last two that I plotted with a slope of -3 and a slope of -4. And now I've got 15 more points to fill in. I've got the point 0, 2, that's got a slope of -4. And something else you can do as you get more comfortable with these is you can utilize the fact that there are patterns that develop in the slope lines to calculate them a little quicker. There's a slope of -5 there, and a slope of -6. But for instance, one of these patterns that I notice is that when I move over 2 units to the right and up 1 unit, the slope lines have the same slope. And so without even calculating here, I can fill that slope in. And that slope is 1, and that slope is 2, and this slope's going to be 3 and 4. We've kind of at this stage identified patterns in the slope lines that are going to help us identify what those slope values are. let's see, at 0, -2, my slope is 4. Here it's 3. Here it's 2. Over here it's 5. And 6. Okay? And so that's what our slope field's going to look like. Basically, I just calculate the slopes at all those points, plot little hash marks for them, and that gives me the slope field. Now, this shows us a picture of what all the antiderivatives of dy dx look like. And I can start at a particular value and sketch an example of a solution curve with that initial condition. Let's look at part B here. We're going to sketch the particular solution that passes through the point where f of -1 is equal to 0. So this is going through the point -1, 0. So what I'll do to sketch that is I will sketch a point at -1, 0. And then I will use the contours of the slope lines to help me determine where exactly this solution curve is going to go. To the left, the slopes get bigger and bigger negative values as we go. So the slope lines are going to look something like that, or the solution curve is going to look something like that. And mind you, this is a rough sketch. And then when it hits this line right here, it goes horizontal. The line that's going through all of these slope lines that have a slope of 0. And then to the right of those, the slope is going to slightly increase. And it's going to be a very small positive here. And a bigger positive, and then it starts to level out as we move in this direction. So my solution curve for that should look something like that. Again, this is just a rough sketch, so realize there's some room for interpretation here. Alright, and then we've got the solution curve that goes through the point where f of 2 is -1, so we want to draw it through the point 2, -1. So I'll go over to 2, -1. And I don't have a lot to work with over here. We've got a gradually steeper negative, and then this is going to start to flatten out a little bit. And there's a sketch of the solution curve for part C that we can fit on this particular grid. So that's how we create a slope field, and how we might sketch an example solution curve on the slope field that goes through a given point. Alright, that's the end of our video for today. See you guys next time. Have a great rest of your day.